Alright, continuing with nucleophilic substitution reactions, let's take a look at some important nucleophilic, I'm using abbreviations now, substitution reactions shown by haloalkanes. Right, let's see which nucleophiles are stronger than halogens which can replace them in haloalkanes. The first one we'll talk about is substitution of X, which is a halogen atom, by OH group. What is OH group? Hydroxyl group. This can happen. OH is a stronger group than X, so that I'll write down the general reaction. If we have Rx and we take a reagent containing OH, for example, we take K plus OH, right? Potassium hydroxide. We'll have to create the conditions of the reaction. Heating is required there, and this is taken in the aqueous solution. What happens is that these two leave together, potassium and X. We have potassium and X here, and what is left behind is R with OH. So the class of compounds that we obtain here is alcohols. If OH substitutes X, OH is a nucleophile, X is a nucleophile. Both are negatively charged, but OH is a stronger nucleophile, thus it is capable of substituting X, and the resulting class of compounds is alcohols. Right? I'll be just writing down the general reactions, because basically you have to study the mechanism of nucleophilic substitution reactions, but I thought it will be proper to give you first the examples that which nucleophilic substitution reactions are possible. Substitution of X by alkoxy group. This is possible. Alkoxy group is a nucleophile. What is alkoxy group? OR, right? It is possible, and because OR is a stronger nucleophile than X. I'll again write down the general reaction. For example, we have Rx. We start with an alkyl halide. We'll have to take a reagent which contains OR group. For example, we take this. Just to differentiate between this R and R, I have put in R dash here. Sodium alkoxide. We create the reaction condition again. These two leave together. This is a byproduct. NaX is a byproduct. It can be NaCl, NaBr, NaI, whatever. What is left behind is R of this and OR of this. Now, as you can see, the class of compounds we get is ethers. ये भी आपको याद रखना है कि when this, which class of compounds is formed when what kind of a nucleophile replaces X. In the first one, when it is replaced by hydroxy group, you get alcohols. This is our second. If X is substituted by alkoxy group, the class of compounds, organic compounds we get is ethers, right? Moving on quickly with the examples. The third one would be, the third possibility is, okay, the alkoxy one, the formation of ethers is known as, add it to that, that reaction is known as Williamson synthesis. Synthesis of ethers. Synthesis of ethers by substitution of X with alkoxy group, right? The third one, third possibility here is that we can substitute this X, substitution of X by CN, cyano group, right? If you do that, we have Rx, and we can take any reagent containing that cyanide group. For example, this is taken as in an alcoholic medium, and heating is done. We get RC triple bond N plus K plus X minus as the byproduct. What is this class of compounds? These are cyanides, and in IUPAC name we call them alkane nitriles. This is an alkane nitrile, right? In common system they're called as alkyl cyanides. So this happens. If you substitute X by a cyano group, the class of compounds obtained is alkane nitriles. Alkane E is retained here because you know the rule that if the name of the functional group begins with a consonant, this E, terminal E of ane ya ein is retained. Right? This is the IUPAC name of this class of compounds. However, in this case, you must remember that जो CN होता है, it is an एम्बिडेंट न्यूक्लियोफाइल. आपने जैसे कोऑर्डिनेशन केमिस्ट्री में एम्बिडेंटेट लिगैंड्स के बारे में पढ़ा, दैट दे हैव मोर देन वन डोनर साइट्स. दे यूज ओनली वन एट अ टाइम, बट दे कैन फॉर्म बॉन्ड्स थ्रू मोर देन वन साइट्स. They're called as embident nucleophiles. In this case also, it can form a bond using carbon. It can form a bond using nitrogen. So the fourth one, we'll take it as substitution of X, again by cyano, but as what? As this, N triple bond C. Actually ये इसमें एक coordinate bond होता है. That is the structure of CN. We'll not go into the details of that. If it makes a bond through through nitrogen, that what happens? We have RX. We take up any such reagent, for example AgCN, silver cyanide, and creating the conditions, the reaction is carried out in the alcoholic medium. Ethanol use किया जाता है and it is heated. If this is how the bond is formed, or it bonds through nitrogen and then we have carbon here. The class of compounds that we get is alkane, alkyl होगा ये, alkyl isocyanide. Right? Just an isomer. It's called as alkyl isocyanide. If your this group nucleophile bonds through nitrogen, if it bonds through carbon, they are cyanides. If they bond through nitrogen, they're called as isocyanides. Right? And this is an important point to remember here. ऐसा ही हमारे पास एक और nucleophile है. I think we are on number 5 or number 4. We can substitute this substitution of X by NO2 group, nitro group. Nitro group is a nucleophile and it is a stronger nucleophile than X. Therefore, this substitution is very much possible. So what happens here is that we take RX, it can be any haloalkane, and we take a group, for example, we take AgNO2. Right, silver nitrite. We create the conditions again. ये reaction भी alcoholic medium में की जाती है. It is heated. Now what happens if this R forms a bond with NO2 via nitrogen? मैंने open करके लिखा है group. This is NO2. It is again an embident ligand. It can bond through nitrogen. It can bond through oxygen. If it bonds through nitrogen, the class of compounds that you get is called as nitroalkanes. This is the information you need to retain in your mind. That कौन सा substituent, कौन सा class of organic compounds देता है हमें. If we substitute it by nitro, NO2, and that nitro forms a bond through nitrogen, the class of compounds obtained is nitroalkanes. Obviously, we'll have AgX as the byproduct. Now, as I said, this NO2 is again embident. It can bond through oxygen also, and this is what can happen. We have started with RX and we have taken up a reagent like potassium nitrite, right? If we have taken potassium nitrite and we have created the conditions, we heat it. If bonding takes place like this, RON double bond O, this is again RNO2. The functional group here is again NO2, but it is making a bond with the R group through oxygen. This class of compounds is called as alkyl nitrites. They're called as nitrites. If it bonds through N, it is a nitro. If it bonds through O, it is a nitrite. So you have to keep all of these details. These are minor details, but these are crucial details. You have to keep all of these details in mind. This will be obviously a byproduct. It depends आप कौन सा reagent यहाँ पे ले रहे हो. We have taken a salt of potassium. Therefore, the byproduct will be a salt of potassium again. Right? We'll continue in the next presentation.